Let me show you how to sketch the graph of f. We have x cubed minus 6x squared plus 9x. Then they want us to sketch this graph. We know that the value of a is positive, means the graph will start by increasing and end by increasing. Okay, y-intercept, we let x to be 0, where there's x, we substitute 0, so f of 0 will give us 0. Therefore the coordinates will be 0 and 0. Therefore we look for x-intercepts by letting y to be 0. Where is y? Y is f of x. Therefore x cubed minus 6x squared plus 9x equals f of x, which is 0. Then we do have something known as a common factor here, which is x. Then we'll take it out. We're left with x squared minus 6x plus 9 equal to 0. Then x equals 0, or you simplify that using the brackets, so it must be x minus 3, not x plus 3. X minus 3, x minus 3 equals 0. Then you simplify, you solve for x equals 3 or x equals 3. So in the coordinate form it will be 3 raised to 0 or 3 raised to 0. And the coordinates up there, we're having 0 is to 0, as you can see. What else? The stationary points. Remember, we said for us to find the stationary point, you do what? Its first derivative equals 0. Then there's a mark for this. Show it all the time. Then you're going to derive f of x. Therefore, it will be 3x squared minus 12x plus 9 equals 0. Then 3 can, or all these numbers are divisible by 3. Therefore, we can say that x squared minus 4x, by dividing all these values by 3, plus 3 equals 0. Then we can simplify it further by the short brackets. 0 equals 0. We have x here minus 3. It will be x minus 3 and x minus 1. Then we solve for x equals 3 or x equals positive 1. Then we can take these values of x and substitute them on the original function, not the derivative, the original. So it is f of 3. It will give us what? Just use your calculator. It will give us 0. And f of 1, it will give us positive 4. Therefore, you write them in a coordinate form: 3 is to 0 or 1 is to 4. These are the stationary points. Then we can sketch our graph. Remember, the y values of a cubic function, do not substitute the x values on the derivative but on the original graph. Note that. Let me try to use the ruler so that I can draw my line straight, or so that it can be nice. I think it's right over here. Okay, that's wonderful. Then we label our Cartesian plane. Okay, this is disturbing me. Okay, we have x here and we have y there. Then let's check all the x axes. We have 3, we have 3, we have 0, 3 and 1. then we can say we're having 4 here, -4, then we'll assume where 3 is, then we have +4, 0, 0 and 0. Then we can say we have 5, then we'll assume where the exact points are. Then let's try to plot here. We'll start with 0:0 at the origin. Let's just use the red color. Then the second one, 3:0, it's somewhere here. So 3:0, we have 3 points here. Therefore, let's use 1:4 because the 3 points are sharing the same location. So this is what we have here, and 3:0 is what we're having here, and this is also what we are having on that same point on the x-axis. So 1:0, 1:4, that's what we're having up there. Then let's try to, so this our graph will look like that. Why? Because a is positive. Then let's try to sketch our graph. It will be like this. My graph is so bad, yo, but it must look nice. Make sure that it looks nice. Okay, let me try to start it here. Oh my goodness, I don't know what to do now. Let me just leave it like this, but make sure that it looks nice. Né? What we're having, we know that we're having our points or our coordinates here as 1:4 and 3:0 as well as 0:0 here. This is the graph of f. I hope you understand this. Then this is the point of inflection. Remember, second derivative equals 0. Then it's all for x, or you can actually use this one. This one looks simpler. You'll add 1 and +3, then you divide them by 2. Then the answer is 4/2 equals 2. Then you'll take it and substitute it on the graph of f to find the y corresponding value, meaning it will be 2 and 2. I hope it makes sense. Then you'll plot it somewhere here. 2:2. So this is very important.